Hi, welcome. In this video, we're going to go through problem 20. And in problem 20, we have to evaluate this integral. And it's easy to see that we should use partial fraction decomposition to do this. And remember, partial fraction decomposition required first that we factor the denominator. So we have x squared plus 3x plus 2, which is easily seen to factor as x plus 1 times x plus 2. Now what we would do is then create two fractions, each of which has as denominator one of the two factors. So let's say x plus 1 here and x plus 2 here. And we know that these two fractions have constants a and b as numerators. And our claim is that the sum of these two fractions would make the inside of our integral, which is our integrand, and that is 5x plus 8 divided by x squared plus 3x plus 2. Got it. Now if those two things are to equal, we must first make sure that their denominators are the same. To do that, knowing how we got here, we know that multiplying by x plus 2 numerator and denominator, therefore multiplying by 1, would ensure that this denominator is identical to this one. Got it. And then, of course, multiplying by x plus 1 here is what will achieve the same goal and getting that denominator to be the same as that there. Now that we've got the denominators all the same, well, at least on this part, let's write them with a common denominator. And we know that that common denominator is, if we multiply these out, in fact, it will be x squared plus 3x plus 2. So that denominator is identical to the denominator on the right side. But the numerator on the right side is 5x plus 8, whereas the numerator on the left side is a times x plus 2 plus the constant b times x plus 1. Of course, capital A is also a constant, right? Now, it's clear that since the denominators are identical, these two fractions will be the same when the numerators are the same. That is to say, when a times x plus 2 plus b times x plus 1 is equal to 5x plus 8. Alright, some cleverly chosen x values will make for efficient solving. If we allow x to equal -2, because this whole thing, that statement, that equality holds for all x, if we choose x equals -2, you'll see that that x value is cleverly chosen. That's because we would get a times 0 there, therefore 0, and then we'll get b times -2 plus 1, x is -2, remember. And since again, this holds true for all x, the left side must equal the right side for all x, in particular for x equals -2. So we've already plugged in -2 on the left side, so let's plug in -2 on the right side to get 5 times -2 plus 8. That will reduce to saying that -b is equal to 5 times -2 is -10 plus 8 is -2. Therefore, b is equal to 2. Sweet. Now, you know that a clever choice of x, another clever choice of x should be x equals 1. Nope, x equals -1. Tricked you. And if you do use x equals -1 and plug it in there for all the x's that you see, you'll get a times -1 plus 2, and therefore just +1, plus b times 0, right? That's why that was a clever choice. And then 5 times -1 plus 8. That immediately reduces to saying a is equal to 3. So there we go. So capital A should equal 3 and capital B should equal 2. And then we will have had that, well, as we started, that for those choices of capital A and capital B, that this will equal 5x plus 8 over x squared plus 3x plus 2. Again, it's probably obvious at this point. That does not hold true for any capital A and capital B. it holds true for the specific capital A and capital B that we solved for. So why don't we, now that we know them, put them there. So where was A and where was B? Okay, got it. A is 3 here, and then B is 2 here. In fact, you can check, use algebra, find common denominators, all that good stuff like we did here, and show that those two sides are equal if you so care. But you're timed on this test, so you probably don't have the time to do that. You want to keep it moving. So you'll write then the integral from 0 to 1 of 5x plus 8. You probably won't even want to write this, but I have the luxury of time as I'm making this video, so I will. So x squared plus 3x plus 2 dx is equal to the integral from 0 to 1, since this now equals what we just found, 3 over x plus 1 plus 2 over x plus 2 dx. And we could separate them as two integrals. We don't need to, but we could do that. 3 over x plus 1 dx plus 0 to 1, 2 over x plus 2 dx. Okay, clear. So this is clearly 3 times natural log of x plus 1, 0 to 1, right? Evaluated at 0 and 1. And then this is clearly 2 natural log of x plus 2, evaluated at 0 and 1. So doing that, you get 3 times ln of, plugging in 1, you get 2. And then minus 3 times ln of, plugging in 0, you get 0 plus 1, so ln of 1. Got it. And then you get plus 2 ln of, plugging in 1, you get 3. And then plugging in 0, you get minus, right? Minus 2 ln of 2. I want to make sure that I did this part right. Did I not forget the minus? Yes, it's 3 ln of, plugging in 1, 2, and then minus 3 ln of, plugging in 0, 1. It doesn't matter anyway because ln of 1 is 0. Therefore, that term is gone with the 3. So this is gone. And then we have 3 ln of 2 is ln of 2 cubed, right? And then we have that plus 2 ln of 3. Actually, sorry, let me backtrack a little. 3 ln of 2 and negative 2 ln of 2 combined to just a single ln of 2. And then that part I will want to write as I had done earlier with the power rule for logs, which is 2 ln of 3 is the same as ln of 3 squared by the power rule of logs. And of course, using the multiplication rule for logs, we can write that sum as a product of 2 and 3 squared inside the argument of ln. And this is clearly the prime factorization of 18. So this is ln of 18, the correct answer choice C. All right, I hope this helped. Take care.